Değerli misafirlerimiz, tekrar merhabalar. Toplantımızın ikinci bölümüne hoş geldiniz. Konutlarda yangın güvenliği ve ETICS yani dış cephe ısı yalıtım sistemleri ile hemen ardından da endüstriyel yapılarda yangın güvenliği, teras çatılar başlıklı sunumlarını bizlerle paylaşmak üzere Rockwool International Yangın Güvenlik Müdürü Sayın Miroslav Smolka'yı yeniden sahneye davet ediyorum.
Okay, so we may now continue with ethics, which is an abbreviation, as you know, for external thermal insulating composite systems. Right here, you can see a picture why ethics can be a problem for fire safety. This was a fire case in France last year. What I want to cover by the overview of fire safety and ethics is some market situation. Again, what ethics can be considered fire safe, ethics and Euro classes, ethics and large-scale fire tests, a couple of words about installation errors, and the fire safety during installation. So what are market trends, what we have observed during the past couple of decades? We can see market in Europe growing very much because of energy prices and energy-saving legislation. Why it was normal a couple of years ago to apply something like 5-6 centimeters on a wall, now it's pretty much common to have 12-15 centimeters, at least in the middle of Europe where I come from. Obviously in the north it can be much more. So we observe thickness of insulation is growing, but thickness of render is going down at the same time. Quality of application, I would put a big question mark here. But who knows that this quality of application may have a big impact on fire safety. These products are used on a wide scale since 1990s. 20 years ago it was I would say niche product. Now it's a mass commercial product with all its consequences. So here are a couple of reasons why we should be concerned about fire safety of ethics. Two examples. Dijon in France, seven people died here. 6 poisoned by smoke, 1 jumped out of the window. This was a fire case when there was a garbage bin next to the facade and it caught fire and it went up to several stories before firefighters arrived. And here in Miskolc in Hungary, it was a different scenario. It was a fire in a kitchen which spread onto the facade, and the flames went up very quickly up to the roof. Also, smoke came through the windows because it was a hot summer night. So the smoke went through the windows and also through ventilation shaft. 2 people died here, not in the room of origin, but in the flat above. So if we ask what ethics is fire safe, we can get plenty of different answers depending in which European country you ask this question. In some countries you can use non-combustible insulation on high-rise buildings, in some countries not. In some countries from different height levels, 12, 16, 30, 9 meters. In some countries you are obliged to use fire barriers or fire belts. In some countries you have to calculate fire load, safe distances from neighboring buildings. You can also consider sprinklers if they are inside or not. In some countries you don't have any regulations. You can apply any insulation and there is no concern about fire safety. So here is an example what a fire barrier of stone wool may look like. You can see that stone wool is quite commonly used as a fire barrier. This measure can improve fire safety to some degree. This is a quite high, quite big fire barrier. I think it's 90 centimeters according to Slovak standards. In some countries you have only 15 or 20 centimeters. So this can be effective if the fire is relatively small. But of course if it's big, the fire can jump over the fire barrier and go up. In the system of CE marking for ethics systems, these are CE marked using Euro classes. This is not a perfect situation, and all the people who are involved in the process are aware that there is a problem, because this is again SBI test. But SBI, the fire scenario of SBI is a burning waste basket inside a room. But ethics is applied on the outside, and there should be some different reasons why they catch fire, not a waste basket inside a room. Again, fire exposure is too small, it's only 30 kilowatts, burning for 20 minutes. Important details are missing here. The flame attack is only on the surface, but in real fire cases, you have flame attack through the window on the bottom edge of ethics. So it's a totally different situation. And as a result of this small fire exposure, all ethics will be A2 or B, regardless of the material. Usually with stone wool you have A2, reaction to fire class for the system, and with polystyrene you have B class. But some countries have different approaches. This is an example from the UK. This is a guide to show what can be possible fire scenarios where ethics or external wall cladding is involved. So you may have a fire outside, waste basket burning. You may have fire inside, and after flashover, the fires climb up the external wall. You may create secondary fires by jumping fire through other stories, or you may experience burning droplets and then another fire in the bottom. And these are pictures from real life cases. You can see everything which was on the scheme before, now it is as a real life photo. Car burning close to the facade, waste basket, and obviously flashover in a room, and the fires going out of a window. Although CE mark has to contain information about Euroclass, many European countries are not satisfied with the situation, and they are introducing their own national test method. This is, for example, the British standard. This facade is 8 meters high. This is SBI, it's 1.5 meters high. I was trying to put these pictures in a bit of scale so that you can see the difference. So obviously, the result you get, the classification you get, it depends on what kind of risk you expect. And it's widely accepted that SBI is not a relevant fire scenario for external wall claddings. So this is the British large-scale test, before test and after the test. Can we start the video now? What I will show you now in the next couple of minutes is not the British test, but this test was made in Canada, but the principle is very much similar. You have a room, you have a fire in a room, and an open window, and it's very important to make all these details of this external insulation system like it is done in practice, so that you have some idea what may happen in case of real fire. And what you measure in these kind of tests is usually you observe propagation of flame upwards, also to the side. You can measure temperatures inside the insulation, temperatures on the surface, and now we are at 5 minutes, and we already have involvement of combustible insulation in the fire. Of course, it's only a matter of time until the rendering may crack, and as soon as some holes appear and oxygen can get in, also fire and hot gases from the fire can get in, you may see a burning of the insulation. So the fire behavior of this system is very, very much dependent on quality of the top layer. In this case, we used fire barrier here. stone wool, 20 centimeters high. And we'll see if it happens or not in stopping the fire from developing. You can also observe burning droplets coming down here. As I said before, the quality of the top layer to a large extent determines the end result. It is possible to pass this large-scale fire test with combustible insulation. If you put the right amount of rendering, the right amount of mesh, of the thickness, of the quality. But what we can see here, the second fire barrier is burning. So, as I said before, fire barrier can help to some degree to stop the fire, but the fire exposure is big enough. It may not be really helpful. If you remember the picture of the Dijon fire, there were also fire barriers, not made of stone wool, with a different type of non-combustible insulation product. But obviously, this was not a big help because fire just jumped over these barriers. And now we are having a complete involvement of facade. The rendering, you can see, is hanging. The integrity of the top layer is lost, and this has to be the end of the fire test. Usually, depending on the national criteria, you can have either 15 minutes or 20 minutes or 30 minutes of criteria for passing this kind of test. And this second part will be a kind of boring one. This is ethics with stone wool. Stone wool as a non-combustible product has the advantage that it can't catch fire under any conditions. You don't have to rely on a very thin rendering, very thin protective layer, and you don't have to be concerned so much about its thickness and about its quality of application from fire safety viewpoint. So here we are jumping to the 10th minute. You can see that heating power is very high. It's at least, I would guess, 2 megawatts. It's surely after a flashover in this room. The fire can reach maybe one meter up, but it doesn't affect the complete system. Because once the system is non-combustible, it just can't spread the fire. Okay, so now we have 20 minutes, still no change. Yeah. And this is the end result. Although you can see some surface damage here, there is no big damage. Apparently it can be easily repaired, no threat to the inhabitants of a building where this is installed. It's the end, thank you. Okay, as I told you, some European countries are even now introducing large-scale test method, even though that testing in Europe is harmonized to a large degree. In these areas where fire scenarios are not agreed, people are not satisfied, some countries introduce new test method. This is a Czech test method adapted from ISO. So you can see also in this case of combustible insulated ethics system, it gives totally different test results from SBI test. This can pass very easily B class in SBI. And a couple of words about application details. We may have nice test results from small scale, middle scale, or large scale tests, but what will happen in real life in fire, it depends very much on the quality of installation. This is pretty relevant everywhere, worldwide. So I'm going to show you just a few examples what kind of application details can have a big effect on fire safety. Most people know that these are problems from the viewpoint of nice facade. But who knows that this is a big problem for fire safety in case of fire? This is a problem of integrity of the top rendering. instead of, for example, 5 millimeters, you may have only 2 millimeters, and in case of fire, it's a very, very big difference what happened to the insulation. This is a solution to, or a kind of solution, I would say, to the case when you don't have very flat, very even surface. Many times installers are helping themselves applying a layer of polystyrene. And although this was a case, this was a high-rise office building where stone wool should be installed, this was installed on EPS. So this is quite common, surprisingly. Or another case, in case of using polystyrene, you have to glue the board not only on the spots, but you have to apply glue around. This is not only to avoid deformation of the insulation board, this is also to avoid having air gap, continuous air gap passing through big heights. As you can see here, this was a picture taken by my colleague from the 3rd floor. He could see the pavement. So in case of fire, this is a very nice chimney where there is a very high risk of fire spread behind. Or, I don't know if you can see this well, this is, I hope, an extreme case, very, very thin glue, very, very thin top layer. So if you apply surface layer here, nobody will see any problem. People will begin to see some kind of problem after a couple of years when it starts to crack, but nobody will see a problem with fire safety until a fire occurs. So let's hope that there will be no fire in this kind of buildings. And the last but not least point here is fire safety during installation. This is a very sad example, a fire which happened in Shanghai 1 year ago. 58 people died, according to official records. And what happened here was that this was a high-rise building, flats for the retired teachers. So also the Chinese government was a kind of involved in this building. That's why it was very quickly, a kind of stopped from publishing any other information about this fire. But what happened here was that combustible insulation was applied on the external surface, and from welding, from a spark, this safety net around the building caught fire. And since there was a lot of combustible insulation on the scaffolding and also inside the building, the fire was started and developed so quickly that very few people were able to escape. And most people died out of toxic smoke inhalation. So let's hope that this was an extreme and only case of this type. And that's why we have to focus not only on the fire safety after it is installed, but also during manipulation with combustible materials on building sites, especially if people are still allowed to be inside. So to summarize fire safety of ethics, as you could see, it is not the matter of fire resistance, because fire resistance is a matter of the load-bearing wall itself. There is very little agreement in Europe and worldwide what ethics is actually fire safe. Fire barrier can help to some degree, but it is not a guarantee that fire will not jump over the floors and spread upwards. Euroclasses, it is already agreed that they are not related to real fire safety on buildings. And the quality of installation is especially important if you use combustible products behind a very thin render. Okay, so thank you very much. This was about ethics. And now my last presentation will be about flat roofs. As you can see, there may be totally different kinds of questions, totally different kinds of problems when we consider different constructions here. In flat roofs, there is also a problem. That's why we are concerned, and we have some fire testing and some fire rules about fire safety of flat roofs. If you ask insurance companies which part of building they consider to be most relevant, they usually reply roof, because they have a lot of experience where, especially in large buildings, if roof becomes involved in fire, it may be a big disaster in terms of material losses. The biggest fires in terms of material losses are the fires where flat roof was involved in fire. This was one of the cases from the past. This is a KAMAZ manufacturing plant in Russia. This roof was huge. As far as I remember, it was 800,000 square meters, several football stadiums, and the flat roof was a steel deck, trapezoidal steel sheet, covered with combustible polystyrene and bitumen top layer. Of course, when fire started inside and got on the flat roof on the top, there was no way to stop this fire. It was burning for several days, and the firefighters were totally helpless to do anything about it. Currently, we don't see a lot of fire cases with the flat roof involved. Maybe I could say it is because stone wool is mostly used in these kind of constructions. In Europe, something like 70% of market share is stone wool. And in many countries, these fire regulations to regulate type of insulation on flat roof was a reaction to these kind of fire cases in their countries. But we have totally different approaches, as I will show you. So again, I will ask a question: which roof can be considered fire safe? We can say a few words about fire from the inside, fire from the outside, because we can have two different fire scenarios for a flat roof. And then what kind of protective measures are used to secure fire safety of a flat roof construction. So what may happen if you have a fire and the flat roof becomes involved in this fire? If the fire is inside a building, the only protection between combustible insulation may be the steel sheet. This is very similar to sandwich panels, and the steel sheets are joined, overlapped, but these screws obviously don't make perfect tightness, perfectly tight. So gases and hot gas and flames can enter the insulation. On top of that, when you heat the insulation, even without direct attack of flames, you can get pyrolysis effect. It means that you experience generation of combustible gases, which may contribute to fire, either on the top or below. And if you have this corrugated steel sheet, you have air channels where fire can spread. So if you ask what is a fire-safe roof, you can get also different replies. By the way, this was also this was a one building in Slovakia. This was a almost finished building during installation of a flat roof. So you can focus on fire on the top. You can focus on fire from below. You can look at some details, or you can evaluate construction by reaction to fire of their components. This is a picture taken from a German DIN standard. This is not a European harmonized standard, but I simply put it here because it shows what may happen if you have a fire inside. If the fire is big enough to attack a roof, fire can penetrate through the roof on the top, or it can ignite combustible material here and start burning on the roof, or it can spread within the construction to the edges. You can also experience burning droplets downwards. And one of the criteria of this particular test is to see if the flame can go through this screen. Because it may also be the flat roof construction which can contribute by combustible material to the development of the fire. Fire resistance is in some countries very relevant, in some countries not. It is strange that one flat roof can be considered legally safe, but a couple of kilometers away in a different country, in European Union, it's a dangerous. It is the same like with the ethics. Here I will show you a short video. We can start it now. This was a fire test where we tested a couple of flat roofs on corrugated steel sheet, and we were using different insulation materials: EPS, PIR, and Rockwool. Looking on the outside, all the flat roofs constructions were the same. You could not tell what is inside. Everything was the same: steel sheet, top layer, bitumen. You might see that this is a stone wool built around combustible insulation. This is a standard way how fire testing laboratories protect the edges from fire entering the insulation material. Of course, this is not a real-life detail, but in this testing you have to somehow secure that you don't have very quick ignition, because you have a downscaled model of a construction, not a real construction here. So you can see a lot of smoke developing from the insulation product, and the view from the bottom. And it was quite surprising that this roof was okay for 10 minutes. But after 10 minutes, it was a sudden ignition of all the surface. So the type of the construction which was here, it might be similar to the Kamaz factory. Once it was started, the laboratory just could not extinguish, and it was only 3 by 4 meter sample. When we started the polyisocyanurate insulated flat roof, we used only 10 centimeters. This is the thermal equivalent, because PIR has a better lambda value than EPS or than stone wool. We were experiencing quite better results, because PIR has a much better reaction to fire class than polystyrene. But what we could see very quickly, just like in the case of sandwich panels, were heavy development of smoke, and we were not allowed to enter the test hall because of the possible toxic effects of this smoke. So you can see also the same type of stone wool perimeter, the stone wool protection around PIR. And we were experiencing much better result than 10 minutes, but eventually we were surprised to see flames in this particular sample after 5 minutes. So it was like one of the edges of the flat roof construction started to burn. What is burning here in case of PIR is not material itself, because PIR burns in the same way like wood. It emits combustible gases, and only these gases are burning. So the laboratory extinguished locally the fire. We wanted to continue, but after a few minutes it was again igniting on the same spot. And here you can see installation of Rockwool stone wool in terms of large scale slabs. Obviously, you can expect that this test result didn't show any kind of large smoke or big flame. There was one kind of problem. I will show you later what kind of problem it was. If we looked at the deformation of the steel deck, because this is one of the criteria of load-bearing capacity, we found that in case of stone wool, the deformation of roof was the smallest, although the rock wool has the biggest density and is quite high, is quite heavy. And this is because of the fact that these slabs, stone wool slabs, if they are screwed through the steel deck, they act as a mechanical stiffening element in case of fire. When the steel loses its strength. So we were quite surprised to see that although Rockwool is heavier than EPS or PIR, it has the best contribution to static properties of this flat roof construction. You can see now the deflection of the flat roof. The amount of smoke is much less than before. Part of it is coming from plastic foil placed here between the steel and the insulation as a vapor barrier. Part of it is coming also from the organic binder in stone wool, where you can have maximum 5% in our products. Here you can also see how all these gaps are carefully sealed to avoid penetration of flames and also access of oxygen to this kind of construction in these cavities. And here, at the time of 30 minutes, there was a small flame here, as you can see. What was burning here was the top layer of bitumen. And it caught fire because due to the deflection, there was a gap created between the insulation material. But you can see that it is also integrity failure, but the amount of flames and smoke is totally incomparable to the previous cases. Okay, so that's all. Thank you very much for that. And I can now continue with the presentation. So you can see the installation of different products here. And just I said, the classes, if you look at figures, it can be 30 minutes or 15 minutes, but you have no idea what was the failure. If it was only a small flame without any big danger to the people, or if it was a sudden ignition of all the surface of the fire. Coming back to insurance companies, which I mentioned, as I told you, some insurance companies pay great attention to flat roof constructions. One of the examples is FM Global, which is a US company, but it's also active in Europe and worldwide. Last year, they changed their approval standard for flat roofs. Before that, you had class 1, which was possible to pass with stone wool and with PIR as well. But last year, they decided to change it, and they include non-combustible core, optional class, so that there is now a clear distinction between combustible and non-combustible core in the flat roofs. And this is a first page of a certificate. No, this is a standard. But I can tell you that Rockwool Canada was the first company to get this approval for this kind of insulation. And if you look on the other side, on the top, I learned from Effectis today that you also use this kind of test in Turkey to assess if the flat roof is safe against external fire or not. This is the French test method, ENV 1187. You can see what happens when different insulating materials are exposed to this kind of exposure. You have burning pieces, burning brands. You can see that the flames are horizontal, so that there is a wind simulation by a fan, but there is also quite strong radiation, heat flux on the top. And as a result, you can observe this kind of behavior in this and this kind of behavior in Rockwool. So this is polystyrene. Of course, you can pass this test under certain conditions. You can optimize your construction, but also our experience shows that if we can just a little increase the heat or the wind, the test result can be completely different. So it may be quite well in terms of wind speed 3 meters per second, but you may have totally different wind speeds in real life. So to say something about external exposure, I have to say that there is no harmonization in Europe. We have European standard, but it contains 4 different test methods, so we have different roof. B roof is a very relevant criterion because most roof fires start at the top, and performance depends on test conditions, like I said now. In regulations, you can also find quite often some recommended details how to secure that flat roof is fire safe. A very usual measure is to place a band of stone wool, of non-combustible fire barrier. Usually it is 2 or 2.4 meters wide to secure that if the roof catches fire, it doesn't spread to very large areas. You can have a firewall passing to the roof upwards, usually minimum half a meter. Or you can have a layer of stone wool below or above or on both sides of combustible insulation. This is quite a fire-safe measure which can improve fire safety against fire from the top or from the bottom as well. And the final picture in this presentation is detail of a Rockwool insulated flat roof tested to external exposure for 1 hour. As you can see, bitumen layer is burnt. It was quite intense flame lasting for, I don't know, 15 or 20 minutes. Intense radiation for 1 hour, but this was the only amount of damage. So we can expect that people will be effectively protected below this roof, even though this fire is quite long-lasting on the top. So to summarize flat roofs, we can say that regulations differ very much from country to country, and they may reflect the past experience with fire cases. That's why we don't have so many flat roof fire cases now. But this is, to me, this is not a reason to say that we can allow combustibles on flat roof because there is no problem. Of course there is no problem because we have 70% of non-combustible insulation here. The biggest losses, the biggest fires are caused by fire from the inside, but we can also see a lot of small accidents with fire from the outside, from the top. So this was, I think, a basic summary about the constructions, flat roofs, sandwich panels, and ethics. If you have any kind of questions, I'm here also during the lunch, so you can contact me. Thank you very much.
Sayın Miroslav Smolka'ya